right, so what we're working on with this lesson is section 5.4, solving radical equations and inequalities. We're really going to be focusing on equations and not doing many inequalities at all, any. So the first thing we need to know is you need to know what an extraneous solution is. And an extraneous solution is just a solution that they're not really solutions. Sometimes you're going to solve things and they don't really work. You get two answers, but it's really only one that works. And so back when you were learning how to solve equations in Algebra 1, your teacher always said to check your equation, to check your solution, and it most of the time worked. But now there's going to be a lot of times when they don't work. And the way we do this, you plug it back into the equation. Mainly what's important is you're going to plug it into the square root. And if you get a negative radical, like a negative square root, it's not possible. Now, here's the thing to remember, though. A square root or a fourth root, any of those, if you have negative numbers, those are not possible. Those don't work. You can get i's, but we won't be solving with i's. But if I have an odd root that's negative, those work. Remember, because you could take a third root of a -1, a fifth root of a -1. Those are okay. But it's when you take the square root or the fourth root or the sixth root, any kind of even root of a negative number, that it doesn't work. All right, so let's go ahead and solve these equations. And so I know that I have to get rid of this third root, but I don't want to get rid of it until I get rid of everything else. And so what I want to do is get rid of this -9 first by adding 9. And so I get the third root of x is 3. And now to get rid of a third root, I do the opposite. And to get rid of a third root, the opposite is take the third power. And so my third root and third power is gone. And so I have x is equal to 27. So now that looks like my answer, but I want to check it. And really, the only place that we have to check it is we have to check it to make sure it works in the radical. So to check it, I'm going to plug in 27 here. And I can take the third root of a positive number, so that works. So answer is 27, and 27 is actually a number that works. All right, let's look at the second one over here. Same idea. I need to get rid of this fourth root, but before I get rid of the fourth root, I need to get rid of things on the outside. So that means I need to get rid of this 2. This says 2 times the fourth root, so I'm going to divide by 2. And so now I get the fourth root of x plus 6 is equal to 12. Now what I hope you recognize is that this 6 is underneath this root. So I can't get rid of a plus 6 yet because I still have that root. So I need to get rid of the fourth root of something. And to get rid of the fourth root, I bring it to the fourth power. And so the fourth root and the fourth power cross off. So I get x plus 6 equals 12 to the fourth. Pretty big number. Take 12 to the fourth power. 12 to the power of 4, which is 20,736, which was pretty big. And now I need to get rid of a plus 6, so I'm minus 6. So I get x is 20,730. But again, I need to check it, and I check it by doing my root only. And so to check it, I'm going to do my fourth root of my answer, 20,730 plus 6. And I don't really have to do the math. I noticed that this is positive. And so since it's positive, I could take the fourth root of it, so this works. So again, when you're checking, you're mainly checking to see whether or not you can take the root of that. And if you can, then it's a solution. If you can't, then it's not a solution. Okay, let's try 2 on your own. So go ahead and copy these 2 problems down. And when you think you have it, go ahead and press play so you can check your work. So the first one you should have added for both sides to get a -6. And then you should have divided by 2 and you get the square root of x plus 6 is -3. And now when I square that, you get x plus 6 is 9. So you should have gotten x is 3. And then I do want you to check it because you always have to check. And again, the only thing I really care about is this root. I'm checking that root. And so it's the square root of x, which I found is 3 plus 6. And 3 plus 6 is 9, which is positive, so I could take the square root. So 3 is my answer. For number 2, you should have added this 4 to both sides and got -2. Third root of x is equal to 12. And then you should have divided by -2 and got the third root of x is -6. And then to get rid of a third root, you multiply by 3. Or not multiply by 3, you take to the third power. And so I get x is equal to, let's see, -6 to the third is -216. So that should be the answer. But again, you have to check it here. I don't care about the other numbers. I'm only caring about my root. So I'm going to check it. And it's the third root of 216, -216. It's a negative. But you can take the third root of a negative. And since you could take the third root of a negative, you're good to go. Okay, let's go back and look at ones that are a little more complicated, where there's a couple more steps. Okay, what's different about this one is that I have the radical and there's nothing near it, but I also have this x plus 1. So what I have to do is I have to get rid of this by squaring. And on the left, you have to square the whole thing. And so really what I have is x plus 1 times x plus 1 equals this square and the square root cross off. So I'm left with 7x plus 15. So now I'm going to either FOIL or distribute. And I get x squared plus 1x plus 1x plus 1. So really it's x squared plus 2x plus 1 equals 7x plus 15. And the issue is, to be able to solve this, we need to get everything over. So I'm going to subtract 7x and I'm going to subtract 15. And so I get x squared minus 5x minus 14 equals 0. And now I have to factor this. What times what is 14? Subtracts to give me 5. Well, that's a 7 and a 2. And in order to get a -5, it's a -7. In order to get a -5, the 2 has to be positive. So here I have two answers. I have 7 and I have -2. So I have to check both of these. All right, so to check again, I'm checking here. I'm just trying the radical. See that? Okay, I'm just checking the radical. And so to check 7, it's going to be the square root of 7 times 7 plus 15. Well, 7 times 7 is 49 plus 15. That's a positive number in the end, and you could take the square root of a positive. So 7 works. Now I need to check -2. So it's 7 times -2 plus 15. Well, 7 times -2 is a -14. But if I add 15, that gives me a +1, and I could take the square root of +1, so this is also an answer. If this would have said -15, then I would have had the square root of a -29, which wouldn't have worked. And so because you can't take the square root, then this would not have been an answer. But because I get a positive number right here, it works. All right, last one that's going to be difficult for you like that to try. Why don't you go ahead and try this one? Start off by squaring both sides and then figuring out what this left side is. And then once you have that, press play so that you could follow along. So you should have x minus 8 equals 4x. So x squared minus 16x plus 64. We've done a lot of these. You should be used to these. A negative 8x and a negative 8x gives a negative 16. And now I'm going to minus 4x, so I get negative 20x plus 64. So I'm looking for my factors of 64 that add to give me 20. So I'm going to write these out so I could check. 1 and 64. Nope, that doesn't work. 2 and 32. No. 4 and I think it's 16. 4 and 16. That's it. 4 plus 16 is negative 20. So my answers are negative 4 and negative 16. And then my actual zeros are positive 4 and positive 16. And so now I need to check those. And so when I check them here. And so I'm going to have the square root of 4 times 4. Well, that's a positive number, so that works. 3. And then I have the square root of 4 times 16. That's also a positive number, so that one also works. So I promise you there will be time when they don't work. I just haven't given you an example of that yet. But there will be times when that happens. All right, let's look at the last problem. And what's wrong with the last problem is that it's written as a rational fraction. And rational fractions can be a little complicated to work with. So what we're going to do is we are going to look at it as a radical. My 4 means I'm taking the 4th root. And then it's 2x to the 3rd. So the first thing I have to do is get rid of this outside number. So I'm going to add, subtract 2 to both sides. And now I need to get rid of a 4th root. To get rid of a 4th root, I bring it to the 4th power. And so I get 2x, that quantity to the 3rd, equals 8 to the 4th, which is 4,096. But now you see how I have a 3rd power. To get rid of a 3rd power, I take the 3rd root. So I get 2x is equal to the 3rd root of 496. So the 3rd root of 4096 is 16. And now to get rid of a times 2, I divide by 2. So I get x is 8. And again, the place that I have to check it is the radical, which is right here. And so when I check it, it's going to be the 4th root of 2 times 8 to the 3rd. Well, 2 times 8 is a positive. Raised to the 3rd power is still going to be positive. And so since it's a positive, that one also checks out. So remember, after you do each problem, you have to plug it into the radical to check it to see if it works. I promise you there will be some that don't work. We just happen to not have any examples of that. Okay, but you move the things that are not touching the radical. You get rid of the radical by raising it to the power of whatever the root is, and then you solve and check your answer.